In this video, I'm going to take a look at the limits of infinite sequences. We're going to start with a formal definition and then do about 4 examples. Alright, so for my formal definition here of the limit of a sequence, I'm going to let a sub n be a sequence of real numbers, and I'm going to consider the limit as n approaches infinity of a sub n, where a sub n is going to be my nth term. If the limit is a finite number L, the sequence converges and L is the limit of the sequence. If the limit is infinite or non-existent, doesn't exist, then the sequence diverges. Alright, so from taking a look at this limit as n approaches infinity of that nth term, we're going to be able to determine whether the sequence converges or diverges, and if it converges, we're going to be able to find the limit. So, for a couple of examples here. Alright, let's say our directions say determine whether the sequence converges or diverges. If it converges, give the limit. So in my first example here, I've got 1 over 1, 1 over 2, 1 over 3, 1 over 4, and my nth term is given by 1 over n. When they give us that nth term, then it makes the problem that much more easy, because now all I've got to do is consider the limit as n approaches infinity. So the limit as n approaches infinity of that nth term, 1 over n. Okay, so basically what this says to do is to take infinity and plug it in for n. So 1 over infinity. Alright, now really this is more of a conceptual idea. On this one, you've kind of got to picture what's going on. As n approaches infinity, as my bottom number gets bigger and bigger and bigger and bigger, what number does this whole entire fraction approach? Alright, so you might have to get a calculator out, do some division here, but if I had 1 over 3, and then 1 over 10, 1 over 100, 1 over 1,000, if I divided those out and turned them into decimals, I would be getting closer and closer to what value. Hopefully this is very, simple to you, and it makes sense that it would approach 0. Alright, but like I said, if not, get your calculator out, do the division, and just see what happens when the bigger this denominator gets. When I go 1 divided by that number, I should be getting closer and closer and closer to 0. Alright, so since I can calculate that limit, then that limit is 0 and it converges. Alright, now in the second example, they did not give me the nth term, alright, but sometimes you can figure out what that nth term is going to be by looking at the pattern that you've got here. So I've got 2 over 1, 3 over 2, 4 over 3, 5 over 4. Alright, if I consider this to be my first term, second term, third term, fourth term, that bottom is just whatever term it is. First term, second term, third term, fourth term. Okay, so I can let that bottom be represented by n. Alright, now how can I get that numerator? Well, this is the first term. Alright, so if I take 1 plus 1, I get 2. Alright, this is my second term, so if I take 2 and then add 1 to it, I'm going to get to 3. So my numerator is going to be n plus 1. Okay, so this is going to represent my nth term. So now I just need to take a look at the limit as n approaches infinity of n plus 1 over n. Alright, now what I would probably do this is I would probably do some algebra manipulation here, break this up into 2 equivalent fractions that are equal to this. Alright, so I would have the limit as n approaches infinity. I would break this up into n over n plus 1 over n. Alright, and you could check, add these 2 fractions, you will come up with this combined fraction right here. When adding like denominators, keep the same denominator, add numerators, it's equivalent. Alright, now do a little bit of algebra simplification here. N over n is just going to be a 1. So then I'm going to take a look at the limit as n approaches infinity of 1 plus 1 over n. Alright, when I take the limit of a constant, I just get the constant, so I know this is 1. We did this limit over here in this first example, 1 over n. As n goes to infinity, this is going to go to 0. So then I can calculate the limit as 1 plus 0, which equals 1. So this limit goes to 1. I can find it. Since I can find it, then I know that the sequence converges. Okay, so 2 examples showing sequences that converge. Alright, now a couple other examples. Alright, let's take a look at this third example here. Let's say my sequence is 2, 4, 6, 8, 10. Alright, again, they're not giving me that last term. Alright, but if this is my first term, this is my second term, this is my third term. Alright, if this is my first term, how can I go and get to 2? Well, 1 times 2 would be 2. This is my second term. If I multiply by 2, 2 times 2 is going to be 4. This is my third term. If I multiply my third term times 2, I get 6. Alright, so basically I am multiplying by 2. So I'm going to take a limit as n approaches infinity of 2n. So I'm going to do a substitution in there with infinity. Alright, well, infinity is a really big number. Multiply it by 2, I have an even bigger number. Alright, so this limit is just going to go to infinity. Okay, so when the limit is infinite or does not exist at all, then it is said to diverge. Okay, so this sequence diverges. Alright, and I don't have a limit. The limit's going to infinity, so it's an infinite limit. Alright, I just say it diverges and I'm done. Alright, for this last example, I've got a sequence that goes -1, 1, -1, 1. Alright, I'm alternating back and forth. I'm oscillating back and forth between two numbers. Okay, and that's all I'm going to do forever and ever and ever and ever here. Okay, so this is called oscillating behavior. This sequence is just jumping back and forth between two numbers. Okay, so this is called also oscillating behavior of the sequence. Alright, and when it does that, then there is no limit, because all it's doing is bouncing back and forth between those two numbers, and so therefore I cannot calculate the limit, so I have no limit. Alright, now if I have no limit, or it's an infinite limit, either one, my sequence is said to diverge. So this one diverges. Alright, so just 4 nice quick little examples of some pretty simple sequences, how you can go about finding out whether or not it diverges or converges by using that limit approach, taking a look at the limit as n approaches infinity. Alright, definitely thanks for watching. Be sure and share with your friends. Thanks.